Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, let's have a go at some questions about reacting masses. So first, we need to be really confident in this topic with how we turn masses into a number of moles. So remember, we have this equation where you take your mass, you divide by your relative formula mass, and that gives you the number of moles in your substance. We also need to be good at using ratios. So let's have a little example of just getting used to ratios first. So for example here, I have 3 moles of A makes 2 moles of B. How many moles of B will 9 moles of A make? So using my first piece of information, 3 moles of A made 2 moles of B, what I have straight away is I have the ratio of these two substances. They are in a ratio of 3 to 2. Now, if I think about the fact that actually I didn't have 3 moles of A originally, I had 9 moles of A, I can think about the idea that that is now 3 times as many moles of A than my original situation. Originally, I had 3 moles of A, 2 moles of B. Now I have 9 moles of A. That is 3 times larger than 3. So I'm expecting the number of moles of B to be 3 times larger than the original one. 2 times 3 is 6. So that's how to think about it logically. But as you can see here, the equivalent calculation that you do is you take that number 9, okay, you divide it by the ratio there, 3, 9 divided by 3, and you multiply it by the ratio of the substance you're interested in, 2. So you've got 9 times 2 over 3, or 9 times 2 divided by 3, 2/3, is 6. Okay, let's apply this to chemistry. Now, so calculate the mass of oxygen required to react with 9.6 grams of magnesium to form magnesium oxide, and we've been given some relative atomic masses here. Mg is 24, O is 16. So first thing to note here is that in my equation I've got 2Mg plus O2 because my oxygen is a diatomic molecule. So I first need my relative formula mass of oxygen, which is 2 of them together. So 2 times the relative atomic mass, 16, gives me 32. Good. Now I can do my table. So remember, this is murmur, mass, relative formula mass, moles ratio, magnesium, and oxygen. So I'm going to fill in the information that I already know, I've just worked out. Mass of magnesium is given to me in the question, 9.6. Relative formula mass of magnesium, just 24, same as its relative atomic mass. And oxygen, I just worked out relative formula mass of 32. And if I look at my left-hand side of the equation, I've got 2Mg plus O2. So my ratio of these things is 2Mg for every 1 O2 here. Okay, next part of my question then is to think about the number of moles of these two substances. So magnesium, remember, I've got my mass divided by my relative formula mass gives me my number of moles. 9.6 divided by 24 gives me 0.4. Okay, and now because I've got my ratio to magnesium for every 1 oxygen molecule, if I have 0.4 moles of my magnesium, then I take 0.4 times a half, or 0.2 moles of oxygen. So see how those two numbers now are still in a ratio of 2 to 1. Magnesium 0.4, oxygen 0.2. Okay, now working backwards, I want my mass, and I've got my relative formula mass and my number of moles. So this time I need to multiply those two numbers together to get the mass of oxygen being 6.4 grams. Okay, let's have a look now at some limiting reagents. So, what mass of sodium fluoride is formed when 2.3 grams of sodium reacts with 2.85 grams of fluorine? And I've been given my relative atomic masses of sodium and fluorine, 23 and 19. First things first, I need to work out my relative formula masses. Okay, so firstly on the left I have my sodium. I just leave that alone because it's not got any subscript at the bottom, okay? But for my fluorine, I have that subscript of 2 because it's a diatomic molecule. So I do need to work out my relative formula mass of fluorine. So what I'm going to do is take those 2 that I have, multiply it by my relative atomic mass. 2 times 19 is 38. And then on my right hand side, I've got this sodium fluoride and I need to work out its relative formula mass. 1 sodium, 23, plus 1 fluorine, 19, gives me a total of 42. Okay, and now let me do my table with my murmur, mass, relative formula mass, moles ratio, and sodium, and my fluorine, and my sodium fluoride. And let me fill in some information that I know. So the information in my question, I got my mass of my sodium, 2.3. I got my mass of my fluorine, 2.85. And now I have got my relative formula mass of my sodium, which is just the same as its relative atomic mass, 23. And for my fluorine, I've got 38, which I just worked out. And if I look at my equation, I've got 2Na plus F2. So that's in a ratio 2 for my Na, 1 F2. And on my right hand side, that gives me 2 NaF. So my ratios are 2, 1, 2 here. Okay, now let me work out my number of moles. So for my sodium, that's its mass, 2.3 divided by RFM, 23, gives me 0.1 moles. And for my fluorine, I've got my mass 2.85 divided by RFM, relative formula mass, 38, gives me 0.075. But remember, I need this in a ratio of 2 to 1. So let's compare the two and see if that's the case. So 0.1 moles divided by 2 gives me 0.05. And 0.075 moles divided by 1 gives me 0.05. So those are different from each other, and my fluorine has a larger number there than my sodium. And this is when we need to remember this piece of information. The smallest number is my limiting reagent. So here, my sodium 0.05, which is smaller than 0.075, is my limiting reagent. And that we have to use that limiting reagent to get your product, okay? So here I had 0.1 moles of my sodium. That is going to produce 0.1 times 2 over 2, or 0.1 moles of my sodium fluoride, because remember, sodium and sodium fluoride were both in the same ratio to each other. So now to work out its mass, remember, first thing I can do is fill in the relative formula mass, which is 42, which I calculated earlier. And now you take the number of moles, 0.1, multiplied by that relative formula mass, 42, gives me 4.2 grams. Okay, now let's look at deducing stoichiometry. So we have got 2.56 grams of sulfur dioxide reacts with 0.64 grams of oxygen to form sulfur trioxide. In what ratio do sulfur dioxide and oxygen react? And we have got our relative atomic masses here for sulfur and for oxygen. So let's first work out our relative formula masses of our sulfur dioxide. So that has 1 sulfur, 32, plus 2 oxygen, O2 there. So 16 times 2 gives me 64. And my relative formula mass for oxygen is just 2 oxygen. So 16 times 2 is 32. Now let me do my table, murmur, mass, RFM, moles ratio, SO2, O2. And let me fill in those bits straight away. Masses 2.56, and 0.64, and my relative formula masses that I just calculated, 64 for sulfur dioxide, 32 for oxygen. Now let's go right ahead and therefore calculate the number of moles of these two things. So just taking each of their masses divided by relative formula mass, 2.56 divided by 64 is 0.04, and 0.64 divided by 32 is 0.02. Okay, now I'm looking at the ratio, so I'm going to try and divide by the smallest number, 0.02. 0.04 divided by 0.02 is 2, and 0.02 divided by 0.02 is 1. So therefore, I have 2 of my sulfur dioxide for 1 of my oxygen here.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, some tips and tricks for this video. So firstly, make sure you don't factor in those big balancing numbers in front of your formula into the substance's relative formula masses. So remember, those are the subscripts that you are looking at. If you have big 2Na, you don't multiply the relative atomic mass of sodium by 2 to get its relative formula mass. You just leave it. However, if you had something like O2 with the subscript 2 at the bottom, then you do need to multiply oxygen's relative atomic mass by 2 to get the relative formula mass for your oxygen molecules. Okay, if you aren't sure how to approach a question, make sure you start by calculating the number of moles from the masses given, because that is an easy way that you can always get some marks. So even if you're not sure how to follow through with the question, do that step first, and that will guarantee you some marks. And finally, to remember that when you multiply the number of moles by the relative mass, it will always give you a mass in grams. So make sure you show that grams is your unit of mass. Don't be tempted to write kilograms.